Most students approach SAT math all wrong. They think that solving a question is all about getting the right answer. But to get a great score, the real trick is to think like the people who write the questions. In this video, I'm going to show you how that mindset makes solving even the hardest SAT percent questions way easier, starting with the basics and working our way through to the hardest questions. There's three basic percent concepts I want to go over. The first one is changing a percent into a number. Normally, these are not that hard, but remember, the SAT writers are educators. They know your weaknesses and they know how to make these things hard. Let's start off with, what is a percent anyway? Well, it's part number, part symbol. And in order to use it in math, we have to convert it into a number first. Let's take a look at this first one, 25%. If I ask a student to convert this into a number, most will simply write it as 0.25. On this SAT test, we are not going to do that. We're going to write it for what it literally means. 25% literally means 25 per, the per is a fraction bar, cent is 100. As long as you always write it like that, no matter how crazy the percent is, you cannot go wrong. And as I mentioned, the people who write this, they're educators. They know students struggle with percents less than 1, bigger than 100, or if there's a variable involved. And I have all of those right here. So let's go through these. To do each one, it's really simple. All we're gonna do, take a look at this first one. All we're gonna do is cross off the percent, fraction bar over 100. Next one, cross off percent, fraction bar over 100. Next one, cross off percent, fraction bar over 100. The final one, cross off the percent, fraction bar 100. So this last one involves a variable, and chances are it will be used in some sort of equation that needs to be solved. But the first three just need to be evaluated. And you can just punch these into the calculator or into Desmos. I want to punch this second one into Desmos because I want to show you something that can happen. So let's head on over to Desmos. I'm going to enter this into Desmos now. So we have 1 divided by 400 divided by 100. Take a look at what it did. It gave us 1 over 400 over 100, and that is not quite right. So I'm going to do this different now. We're going to open a paren, 1 divided by 400, close paren, arrow over, divided by 100. This one looks a little different. It looks like it should look, and there's the correct answer. So you have to be careful about this. You must always look at what you typed in and see if it looks like what you wanted it to look like. The next basic concept I want to cover is converting a sentence into an equation. To do this, there's only 2 words we need to know. Of means multiply, is means equal. Let's put these to use to convert this sentence into an equation. The first thing I'm going to do is replace the is with equal. And then I'm going to replace the of with a multiplication symbol. And then this crazy looking percent, don't worry about it. Just do what we always do. Scratch out the percent symbol and put it over 100. And then the next step is we just feed this into Desmos and have it do the work for us. Let's head over to Desmos. I'm going to enter this into Desmos. So we have 13 equals, open paren, 1 divided by square root p, close paren, arrow over, close paren, arrow over, divided by 100, arrow over, times 650. Okay, so it's not giving us an answer though. So to get the answer, we have to replace the equal sign with the squiggly line called tilde. But if you want to call it squiggly line, I'm good with that. So we replace that with tilde, and it gives us our answer of 0.25. The final percent concept I want you to know is percent change. On the SAT, there are 2 kinds. The first one is a percent more than a value. So for example, 25% more than 100. The wording on that could be changed to a value increased by a percent. So for example, 100 increased by 25%. To do these problems, you need to know this formula. I realize that over the years, you've learned a lot of formulas and you have forgotten a lot, and that's okay. But this formula right here, it is here to stay. It'll be on the SAT and any future standardized tests that you take. To use this, our value in this case is 100. We pop it in place of 100. And we put the percent in place of p, and then we feed this into the calculator, and out comes 125. The second percent change is a percent less than a value. So for example, 35% less than 100. And that's the same thing as a value decreased by a percent. So for example, 100 decreased by 35%. We're going to use this formula here, which is the same as the one above, except there's a minus sign because it's a percent decrease. So we put the value in, we put the percent in, we put it into the calculator, and out comes 65. Let's read through this question together and put this stuff to use. A store buys a shirt for $100. The store's shirt cost is increased by 25% to get the shirt regular price. But then the store has a shirt sale and the shirt regular price is decreased by 25% to get the shirt sale price. What is the shirt sale price? Now, I realize some of you out there are probably going, wait a minute, if you increase by 25% and then you decrease by 25%, those things are just going to cancel and we're going to get 100. Don't you dare do that. We're going to work through this and see how it plays out. There are two ways to do this. We can do it in parts, or we do it in pieces and feed the answer one into the other, or we can just stack all the operations. A lot of students will try to do it in parts, and that's why this thing's on here, because the SAT writers, they create problems in a way where you can't do that. You have to be comfortable with stacking or you just won't be able to do the problem. But I'm going to go ahead and do it the first way so that you can maybe relate to it. So the first thing we do is we take the 100 and we put in our formula for value, and then we're going to increase by 25%. So we were 1 plus 25 over 100. And if we put this into the calculator, we get 125. And then we're going to take that answer, we're going to move it down here, and then we're going to do the decrease to it. So I'm going to open a paren, 1 minus 25 over 100, close paren. If I put that in the calculator, I get 93.75. So it is not 100. And it is the right answer. Now let's do it the second way, where we actually stack the operations. So we're going to start off the same way. We're going to take the 100, and we're going to open a paren, 1 plus 25 over 100, close paren. But then we're not going to feed this into the calculator. We're just going to understand that this is the regular price of the shirt. And then what we're going to do is put the decrease right next to it. So we open the paren, 1 minus 25 over 100, close paren, equals. And then what we do, we feed the whole thing into the calculator or Desmos at the same time, and we get the same answer, 93.75. I'm going to enter this into Desmos now. 100 times, open paren, 1 plus 25 divided by 100, close paren, times, open paren, 1 minus 25 over 100, close paren, and there's my answer, 93.75. Now let's look at the medium problems, which combine the basics we just learned with some twists that are classic to the SAT and other standardized exams. Reading the first problem, I see we have a jar of marbles. Some are red, some are blue, some are white. So I'm going to go ahead and write a relationship for that. So we have R plus B plus W equals 120. All right, then I see that 12 of the marbles are red. So next line down, I'll write 12 marbles plus, but then we're given a relationship between the blue ones and the white ones. So the question is it 2B equals W or W equals 2B? I'm going to go ahead and write both those down. 2B equals W, and then down there, B equals 2W. And we're going to test these out to see which is which. In the first case, I could put 1 in for B, and if I do that, I get 2 for W. Now, is that twice as many blues as white? No, it's not. Next one down, just double checking. If I put a 1 in for W, I get 2 out for B. Now, is that twice as many blues as white? Yes, it is. So I'm going to go ahead and use that one. And I will replace the B with 2W. I'll write that in, plus W equals 120. Now, I look at what it's asking me to find, what percent of the marbles are white. So it looks like I want W anyway, so I didn't need to keep the B. It was okay to take it out and put the W in its place. Finishing it off, I add these up. I get 3W equals 108, divide by 3, get 36. And then writing it as a percent, because I'm reading the last sentence there and it wants to know what percent are white, I say W percent equals 36 over 120, which is 0.30, and that's the same thing as 30%. Let's read the second one together. If X is decreased by 0.5%, the result is 250 less than X. What is X? When I wrote this one, I intentionally made the left side have a decrease, but it's percent, and then the right side has a decrease, but there's no percent. I did it intentionally. Let's go ahead and convert this sentence into an equation. So the value on the left that's being decreased is X, and it's being decreased by 0.5%. So I'm going to put X open paren, 1 minus 0.5 over 100, close paren, equals. And then the question is this going to be 250 minus x or x minus 250? So you can test it out. If it's 250 minus x and x is 300, then that would be negative 50. That's not going to work. If it's x minus 250 and x is 300, 300 minus 250, that's 50. That will work. So I'm going to write x minus 250. The rest of this, we just feed it into Desmos. So let's head over to Desmos and take a look at that. I'm going to go ahead and input this into Desmos, but before I do, I have to swap out the variable. X is a variable that's reserved as the independent variable in Desmos, and Y is reserved as the dependent variable, so we can't use them for what we're about to do, evaluating. So I'll just swap it out. I'll pick any letter other than X and Y. I'll pick A. So here we go. So we have A, open paren, 1 minus 0.5 over 100, close paren, equals A. Don't forget to swap it out everywhere. So A minus 250. And if we hit enter, we get 50,000. Let's read this last one together. If X percent of 300 is Y percent of 120, what is the ratio of X over Y percent? This is a classic SAT question and on other standardized exams. A lot of students assume to solve it, you need to solve for X, solve for Y, make a ratio, and get your answer. I would say maybe 1 time out of 10, that's actually the way to do it. 9 times out of 10, not only is it not the way to do it, it's impossible to do it. And that is this case. Let's just go ahead and set it up and see how it plays out. So I'm going to write X percent of times 300 is equals Y percent of 120. At this case, I'm going to go ahead and simplify what I have. So I'm going to divide the left side. I'm going to divide 300 by 100. I get 3. And then on the right side, I'll just go ahead and divide 120 by 100. I get 1.2. Writing this cleaned up version, I got 3x equals 1.2y. And then I take a look at, again, what I'm looking for is x over y. And I'm thinking, if I just divide both sides by y on the left, I'll get x over y. And I don't know how these numbers are going to play out, but I do know that's a step in the right direction because it looks like what I want my answer to look. So I'm going to divide both sides by y. So divide the right side by y, left side by y. And then I'm going to write a cleaned up version. So 3x over y is 1.2. And that's it. And then at this point, it's pretty clear we just need to isolate the x over y. So we're going to divide both sides by 3. So we get x over y equals 1.2 over 3. And if we divide that out on a calculator, we get 0.40, which is 40%. It's really important to not write 0.40 as your answer. If you look at what they're asking for x over y written as a percent. So you got to convert the 0.40 to 40%. It would be tragic to miss this question after doing all this work just because you didn't read the final part about what they're asking for. And now the hard problems. The SAT typically makes problems hard in 2 ways. Number 1, they're usually multiple step problems where you have to set up the first part of the problem, solve for something that you need to use in your second part of the setup. The second thing is the problems are usually unfamiliar. So you can't really see the whole pathway from start to finish. For students who've been in advanced math classes, they are far more likely to at least start the problem. For students who have not been in advanced level classes, they are far less likely to at least start the problem. The good news, though, is even if you haven't been in advanced level classes, you now have everything you need to set these up and get them right. Let's look at the first problem. As I'm reading through this, I'm seeing a bunch of relationships, and I think we're going to set up a bunch of equations from this. So the first one that I see, and we're going to go ahead and square bracket these, is A is, so I'm going to square bracket that, open, 5% less than the mass volume B, close bracket. And then the next one is, we got a relationship between B and C. So open square bracket around the B, close it at the end of C. And then finally, we have a relationship between A, B, and C. So let's square bracket those. All right, it's time to now set up equations for each one of these. So the first one is A is, and we're going to be changing a value. So what value are we changing? We're changing B. So B, open paren, it's percent decrease. So 1 minus 1/5 over 100, close paren. Okay, that one's done. Next line down. B is, so B equals, and then here, what value are we changing? We're changing C, so C, open paren, 1 plus 4,900 over 100, close paren. All right, and then the final one is A plus B plus C equals 6054. Okay, so it looks like we have to solve 3 equations simultaneously. It's a classic problem on the SAT, and you're gonna have to figure out what letter you want to keep. So we're going to use the first 2 equations. We're going to substitute somehow those into the third equation, and we're going to have to narrow it down to a single letter. What letter do we keep? The trick, find the letter that shows up in all 3 relationships. The one that I'm seeing is B, 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 B. So that's the one we're going to keep. We're going to substitute A and C out of the bottom equation. So looking at this first equation, A is, it's set up, A is in terms of B. So I can write this first part and remove the A and put B, open paren, 1 minus 1/5 over 100, close paren, and then plus. We're going to keep the B, B plus, and now I got to get rid of the C. This next equation down, B equals C with this multiplier, it's not really set up for that yet. So we have to isolate the C before we use it. So I'm going to divide both sides by 1 plus 4,900 over 100, and we'll do it to both sides. And then I clean these up, and I get that that's equal to C. So now I'm good to go. I can now replace the C in this next equation with B over open paren, 1 plus 4,900 over 100, close paren, equals 6054. Now this thing looks busy as heck, but the good news is all we gotta do is feed it into Desmos and have Desmos do the work. So let's head on over there. I'm going to go ahead and input this into Desmos. So we have B, open paren, 1 minus 1/5 in parens, divided by 100, close paren, plus B divided by, open paren, 1 plus 4,900 over 100, close paren, arrow over. And I'm just going to go and use the tilde right away. So tilde, 6054. And there's my answer. B is 3,000. Okay, so now to get A and C, we could type 2 more lines and type in the A part and the B part, or the C part. But instead, I'm going to try to save some time here. I'm going to hit that cog wheel there, and I'm going to hit copy, copy. And now I have 2 other lines that are identical to the first one. And this is important. Like the first term, when we put this together, the first term, the B with the stuff being multiplied next to it, that was actually A. And then the middle term is just B. And the last term, the B with the stuff over it, that's actually C. Okay, so I already have this stuff there. So now in my second line, what I will do is I will go through and I will delete the second 2 terms. So here I go, delete, delete. And then I'm going to replace the 6054 with A, because that first term then is A. And I'm going to put 3,000 in place of B. So here I go. And there's my answer. So you don't really need to retype this stuff, and if you're comfortable doing it this way, you can save yourself some time. Now let's do the last term. The last line. The first term is your A term, the next one's B, and the last one, the B with the stuff over it, that's C. So let's get rid of the first and the second term. So let's go ahead and do that. Delete, delete. And then I'm going to replace the B with 3,000. And then finally, on the far right, that is my C term, that's C. So I'm going to replace the 6054 with C, and I do that, and there's my answer. Let's head back over to the worksheet. Let's take a look at what the final thing it's asking for. It's asking for 1/3 of the sum of A plus C. So from Desmos, we figured out that A is 2994, and that C is 60. So we're going to write 1/3 of means time, so open paren, 2994 plus 60, close paren, equals, and then the sum of those guys is 3054 over 3, and that's equal to 1018. And if I look, I'm going to double check, is this what they're asking for? 1/3 of the sum of A and C? It is. As I'm reading through the second problem, I'm seeing that we have some lengths and an area that are going to be increased or decreased of a triangle. And so what I'm going to do is I'm going to square bracket these percent changes. So the first one comes at if the base, so open square bracket, and we're going to close that at the end of P%. And as we read a little further, we see the height. So we're going to open square bracket there and close the square bracket at that P%. And we have resulting triangle area. So open square bracket at that triangle area and close it at the end of the original triangle area. Somehow we got to create an equation here, of course. So what do we do? I mean, what kind of equation do we set up? Well, I'm seeing in two places is the area of a triangle. So I'm going to start by writing the area of a triangle formula. So I'm going to write 1/2 base times height equals A. And then what I'm going to do is I'm going to start substituting in these parts that are in the square brackets. So as I'm working through this, I'm saying, okay, I got 1/2. And then we have the base. Well, what was the original base? Well, that was a 6. So I'm going to put 6. And then we're going to be changing that value in the first square bracket. It says we're going to decrease it by p%. So open paren, 1 minus p over 100, close paren. And then the next part's base, or I'm sorry, height. And the original height was 8. So I'm going to write an 8. And then we're going to be changing that. And so I'm looking here in the second square bracket, we're going to increase by %. So I'm going to open paren, 1 plus p over 100, close paren. And then it says the result is equal, so equal. And then it says something about the original triangle area. So I'm thinking, well, they don't give us that, but I can get it. So I'm going to write the formula for the area of the triangle again. So A equals 1/2 base times height. So we have 1/2 times 6 times 8, and that'll give us 24. That is the original triangle area. So I'm going to put that after the equal sign. And then we're going to be changing that by decreasing it by 6.25%. So open paren, 1 minus 6.25 over 100, close paren. So I have one equation, one unknown. At this point, we just feed this into Desmos. So let's head on over to Desmos. I'm going to go ahead and input this into Desmos. So we have 1/2 times 6 times open paren, 1 minus p over 100, close paren, times 8 times open paren, 1 plus p divided by 100, close paren, equals 24. Open paren, 1 minus 6.25 over 100, close paren. There's my answer, 25. Let's go back to the worksheet. In Desmos, we found that p is 25. The final thing here is to read the question and make sure we're giving them what they're asking for. So at the very end, it says, what is p? It's not asking for p% or 100 times p or something like that. It just says, what's p? P is 25. We're done. At this point, you might be wondering, you know, Desmos is doing a lot of the heavy lifting for us here. I mean, is this legit? I mean, why do the SAT people set it up this way? Well, there's a very, very good reason for it. Before the digital blue book came out in 2024, the previous years, the old SAT, there were a lot of criticisms. The test was way too long, way too draining, and maybe isn't reflecting the student's accurate performance. So what they did was they shortened it up, fewer questions, more time per question, and within the harder problems especially, they group multiple concepts. And so the problems are a bit harder, and the algebra portion it can be kind of ridiculous. So what the SAT creators are doing is they're going, okay, look, if you can just set this up, and of course we have to embrace technology. So if you can set it up and feed it into Desmos and get that answer, we're good with that. And what they found is that this SAT test actually fairly accurately predicts a student's knowledge and skill set. So it all works out, and it is legit, and I strongly recommend you learn to embrace Desmos. And finally, I've created a list of every % problem available on the digital SAT PDFs, and they're written right here. If you could do me a huge favor, take some time and go work through all those problems, and then come back to the video in the comments section. Let me know how you did. In return, if you have any questions about any of the problems that you did, I will do my very best to answer your questions for you.